Okay, we are asked to solve this partial fraction decomposition. And so what we're doing is we're taking apart this. Normally we're used to putting these together, and we're learning now to take them apart. So the first thing I'm going to have to do is you are going to have to factor the denominator if it's not already factored. And so here we can see that this factors into plus 7 and minus 2. This gives us the 14 and the plus 5. And so this is all over x, and what we're going to do is we're going to divide this into two parts. So we have the first part, which is the x plus 7, plus the second part, which is the x minus 2. So we're really taking apart the denominator, but we don't know yet what's in the numerator. So we're just going to plug in random variables, in this case a and b. Now, as long as you just have x's in each of your terms, like we do here, you're able to just use a and b. I'm going to talk about a little bit if you have an x squared in there, if you have a quadratic. You're just able to put in whatever variables, and obviously using a, b, c, d, whatever is a simple way to do it, but you can use any variable you want. And now to solve for a and b, what we're going to do is we're going to times by the least common denominator. So I'm going to times by this x plus 7, x minus 2. And that on this a, x minus 2, because obviously if I times by x plus 7, x minus 2, the x plus 7s are going to cancel out. And then here, the x plus 2s are going to cancel out. And on this side, they're all going to cancel out. So then you're going to get to this. Then what you're going to do is you're going to try to, what you're going to do at this point is you need to put in some values for x to solve this. And so what you're going to do, what you want is you want to be able to zero out one of these. So what I'm going to do is I'm going to put in first x equals negative 7. And x equals 2, because I know those are going to give me zeros. So if I do x equals 2 first, I have a times 0 plus b to the 9th equals 2. Now this is allowing me, by choosing my x, I'm going to solve, and it's going to, I've chosen wisely so I can cancel out my a, and I've got 9b equals 2, so b equals 2/9. And I'm going to do the same thing to the other one, and I'm going to do x equals negative 7. And so then I have a equals negative 9, negative 7 minus 2, plus b to the 0 equals negative 7. So I've got negative 9a equals negative 7, so a equals 7/9. So what I'm going to do is I'm going to go back to my thing here. And this then becomes, what did I say this was? I can't remember from one thing. 7/9. And this becomes 2/9. But you might as well clean this up. So I can clean this up. And I'm going to write this down over here. And I can move my 9 to the denominator. So I'm left with 7 over 9, x plus 7, and 2. I'm writing this down so I don't forget, and then I'm going to come down here and actually write it out for you. Let's see here, insert page break. Okay. So I'm left with 7, 9 times x plus 7, plus 2 over 9, x plus 2. So what I've done, x minus 2. And then this is just a partial fraction, so it's not equal to anything, and that was the x, the minus was here. And so what I've done is I've taken that, and really since it's in the denominator, I was able to move the denominator down. And obviously if you have problems with that, you should go back and review working with fractions. So my first one here is 7, 9, x plus 7 plus, and then I have 2, 9, I'll need to go back for my x, minus 2. And so that's how we do these partial fraction decompositions. And you're going to find that there are times when it's better to have the smaller individual fractions than the one big one. We've always, to this point, went one way. We went to try to get it in one big unit. But in this case, we're learning how to go backwards, which often becomes a useful tool.